One of the critical components driving the advancement of AI technology is the development of AI chips. In the contemporary technological landscape, artificial intelligence, AI, has emerged as a transformative force, permeating various aspects of modern life. From virtual assistants to autonomous vehicles, AI applications rely on specialized hardware to power their computational prowess. One of the critical components driving the advancement of AI technology is the development of AI chips, also known as AI accelerators or neural processing units, NPUs. These chips are designed to execute AI algorithms swiftly and efficiently, enabling tasks such as image recognition, natural language processing, and autonomous decision-making. The global race for AI chips has intensified in recent years as nations and corporations vie for dominance in this critical domain of technology. Historical context. The quest for AI chips can be traced back to the early days of AI research. In the 1950s and 1960s, pioneers like Alan Turing and Marvin Minsky laid the theoretical groundwork for artificial intelligence. However, it wasn't until the advent of powerful semiconductors in the late 20th century that AI started to become a practical reality. The emergence of GPUs, graphics processing units, in the 1990s marked a significant milestone, as these high-performance chips were found to be well-suited for parallel processing, a key requirement for many AI algorithms. The global landscape. Today, the global landscape of AI chip development is characterized by intense competition among major technology companies and ambitious startups. Leading the pack are industry giants such as NVIDIA, Intel, and AMD, each investing heavily in AI research and development. NVIDIA, in particular, has established itself as a dominant player in the AI chip market with its GPUs, which are widely used in data centers for training deep learning models. Meanwhile, other players like Google, Microsoft, and Amazon are also making significant strides in AI chip design. Google's Tensor Processing Units, TPUs, and Microsoft's Project Brainwave are examples of specialized hardware optimized for AI workloads. These companies recognize the strategic importance of AI chips in powering their cloud services and enhancing the performance of AI applications. Beyond the traditional tech sector, there is also a growing interest in AI chip development from governments and research institutions. Countries like China and the European Union have launched initiatives to support homegrown AI chip projects, viewing them as essential for national security and economic competitiveness. In China, companies like Huawei and Alibaba are investing heavily in AI chip research, while the EU's Horizon 2020 program is funding collaborative projects aimed at developing next-generation AI hardware. Technological trends. Several key technological trends are shaping the evolution of AI chips. Specialization. As AI workloads become increasingly diverse and complex, there is a growing demand for specialized hardware optimized for specific tasks. For example, inference chips are designed to execute pre-trained AI models quickly and efficiently, while training chips focus on accelerating the training process itself. Heterogeneity. Modern AI systems often comprise a mix of different types of processors, including CPUs, GPUs, and dedicated AI accelerators. This heterogeneous computing architecture allows for greater flexibility and efficiency in handling various AI workloads. Edge computing. With the proliferation of IoT devices and the rise of edge computing, there is a growing need for AI chips that can perform inference tasks locally without relying on cloud-based servers. Edge AI chips are designed to meet this demand by delivering low-power, high-performance computing at the network edge. Energy efficiency. Power consumption is a significant concern in AI chip design, particularly for mobile and embedded applications. Efforts are underway to develop energy-efficient AI chips that can deliver high performance while minimizing power consumption, enabling longer battery life and lower operating costs. Challenges and opportunities. Despite the rapid progress in AI chip technology, several challenges remain. Design complexity. Developing AI chips requires expertise in areas such as semiconductor design, computer architecture, and algorithm optimization. The complexity of these tasks can pose significant challenges for chip designers, particularly in the rapidly evolving field of AI. Manufacturing constraints. Fabricating AI chips at scale requires access to advanced semiconductor manufacturing facilities, which are costly and in high demand. As a result, there is often a bottleneck in chip production, leading to supply chain disruptions and delays. Ethical and regulatory concerns. The widespread deployment of AI technology raises ethical and regulatory questions related to privacy, bias, and accountability. AI chips, in particular, have the potential to amplify these concerns by enabling unprecedented levels of surveillance and control. Global competition. The global race for AI chips has geopolitical implications as nations compete for technological supremacy in this critical domain. Tensions between the US and China, in particular, have led to concerns about the politicization of AI chip development and the potential for a fragmented global market. Despite these challenges, the global race for AI chips also presents significant opportunities for innovation and collaboration. By leveraging the collective expertise of researchers, engineers, and policymakers from around the world, we can accelerate the development of AI chips and unlock their full potential to transform industries and improve lives. The global race for AI chips is a testament to the transformative power of artificial intelligence and the critical role of hardware in realizing its full potential. As nations and corporations compete for dominance in this strategic domain, it is essential to strike a balance between innovation and responsible stewardship. By fostering collaboration and dialogue among stakeholders, we can ensure that AI chips are developed and deployed in a manner that benefits society as a whole, while addressing the ethical, regulatory, and geopolitical challenges that lie ahead. In doing so, we can harness the power of AI chips to drive innovation, economic growth, and human progress in the 21st century and beyond.